Disciplinary research is necessary condition for science advancement, but it is not a sufficient condition for real-life problem-solving and technological innovation, because in these cases, interdisciplinary research and communication are also necessary. So Jeremy doesn't agree with me. He agreed with that, but he says that for the advancement of science, interdisciplinary research is also required. So I told him I agree with him. But anyone to agree or disagree with him would require to have the same notion of science, to perceive science in a similar way, not different, perception of science, and to be sure that we are talking about the same way when we talk about knowledge, because there is some consensus about knowledge as justified belief, but you don't find this kind, at least I didn't find it, this kind of consensus with regard to what the word justified means and what are the methods to justify a belief. Different disciplines would use different methods to justify the belief. So as soon as you get into that word or in the word science, you start having disagreement according to the epistemological values of each person. And this epistemological value many times depends on the discipline in which the person is making his or her research. So I found this kind of disagreement, which means that I don't disagree with him, but my problem is that a lot of people will disagree with him, depending on what we understand by science and by knowledge. But something that I don't think that anyone would disagree is with the logical reasoning. I think, maybe I'm wrong, but I think that this is a logical thinking. There is no interpretation here. I mean, if you have a disciplinary knowledge, if you have science with different disciplines, real life has no disciplines. It's what Aristotle said. The human mind needs to separate, to analyze things that are confused in the world, in the real world, in order to understand the world. And an example he used, I couldn't verify what I'm going to say, okay? I just read about it, but I couldn't verify that with Aristotle's writings, okay? Is the example, the metaphor he provides us to understand what he's saying is color and surface. There is no surface with no color, and there is no color that is not in some surface. But if you confuse the concept of colors and surface, you will be confusing optics and geometry. You see? So you need to separate these two concepts in order to have geometry and optics. But in reality, they are not separated. So when you have to deal with reality, you have to merge, to relate, to synthesize this concept coming from different disciplines. So there is no way, I cannot see any way that you can deal with real life problems. Can you decide with whom you're going to get married with some discipline? Can you solve the war in Iraq with a discipline. Can you solve the problem of poverty in any country inside the discipline? All these problems require a multidisciplinary team. So, to be effective, a multidisciplinary team got to have at least interdisciplinary communication. At least. And probably they would need to have interdisciplinary research, not just interdisciplinary communication. So, this is why I feel that this affirmation is a logical affirmation. It's not an affirmation that you can agree or disagree with it according to the interpretation of each word. And this is the disagreement I have with him, not with his position, but his position will generate a controversy. It's generating a controversy. I agree with him, but not all people agree with us. So I prefer to go to something that it's not the result of an interpretation, okay? It's qualitative logic, that's it. There is no interpretation here.
Let me, however, provide one interpretation. This is a statement that is undoubtedly true, but it still has a historic and a hierarchical context. There have been several disciplines that have emerged, and I'm sure if I go back far enough, I don't know what they are. But I do know that operations research
yes.
and systems engineering and software engineering and systems analysis have all begun as ways to integrate disciplines and to move to the point where asking questions becomes as important as finding answers.
Yes.
After we do this, then that discipline becomes a discipline. It's not perfect, but it answers some questions. It allows you to pose others that you couldn't pose. And then you get to a new generation of questions. That means you have to do it again. So while I agree with the statement, one generation's interdisciplinary research and communication may, in the next academic generation, become a discipline.
Yes, you're right. I promised something to him that I forgot about it. He was going to tell you something before starting that so the idea of the video of the conversational session is to provide you with access to what's happened here in order to fill gaps that you might have after this session is over. And maybe filling these gaps, accessing the video would make the paper that you have, you might do as an option, might improve it. At least in my case, the third plenary session, the third conversational session that we have today, I am sure that I'm going to go at least 5 times through the video, because I'm working on that. And your opinion, most of your opinions are going to be valid. So I'm going to write it down as an informal conversation with you, because it's an informal conversation. But I'm going to reference the video as the source. Instead of referencing a book or an article, I'm going to reference the book as the source. So someone told me, hey, this is not orthodox. I said, so what? What's the problem with that? I mean, a lot of people make references as informal in the conversation. Why I cannot do it and reference the video? You see what I mean? You can do the same thing. Any good reflection that you might hear from him, you can include it in your paper and you're referencing, because it was a good reflection of him, but you need it for your paper. You see? So, a conversational session, by definition, starts with questions. Not the way we started. So, we are having this kind of question, and you can add others. Is this affirmation right? She says, for example, yes, it's right, but it's not enough. If not, why? If yes, why? Just to answer that might require a position paper or a reflection paper as an answer. What are the implicit and or the explicit relationship between science and engineering? With science and engineering, we are problem solving and technological innovation. More and more universities are using the word innovation, as you will have noticed, here in the States and in Latin America and in Europe. Sometimes I read the thing that I'm reading, and I cannot understand how the guy who wrote that is not managing the concept of innovation. Many times it's confused with applied research. Sometimes it's confused with invention. If you got an invention, you need to market it and to sell it in order to be innovation. If you don't market your creation, your invention, if you don't patent it, that's a legal issue. If you don't market it, if you don't sell it, by definition, it's not an innovation. It's an invention. So how many universities have department of marketing and sales? So what they are talking about when they are saying that their objective is to produce an innovation, what they are talking about? Do they know what they are talking about? I mean, innovation is not a scientific concept, it's an economical concept. So one way to do it is to relate with industry, to produce entrepreneurs. How many universities are producing entrepreneurs? I'm not sure if they are. I mean, I cannot accept to myself that such a prestige university would not know what they are talking about when they talk about innovation. We are producing innovation. Which one? Which one? Give you an example. Someone else outside of the university probably is producing the innovation, but you didn't produce it. It was produced indirectly, but the university is not producing it.
I'll say one more thing against that.
Yeah.
Process innovation is not the same thing and may occur at universities.
You're right.
One thing I might say, though, I do have I won't say it's a disagreement, it's an expansion. I think we take these terms, not very good, I haven't understood that. I think you're using the word innovation true in an economic sense. But that's only to be really interdisciplinary in the application of language. I think linguists would agree. If you take a term that's been used in an economic area, you can apply it in another. Now, just to crossover. We talk about innovation because it's an innovation because it is out there economically, marketing, sales, blah, 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 blah. Why cannot you have the same concept applied to some other area? It's like in psychology. So we have an idea in psychology, blah, blah, blah. It's an invention, something new. And we say, okay, now, it becomes an innovation because now it goes out there and it's accepted. by the American Psychological Association and others, and is, quote, marketed and sold and used in society. So I would argue that the concept of innovation not only applies to economics, it applies to all these other areas. So innovation, I use the word innovation as something that stands the test of time and acceptability in society in these various areas, economics, psychology, education, blah, 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 blah. So innovation does not only apply to the economic world, it applies in all of these other areas. It's an expanded concept. Right. Innovation basically means renovare. It means to renew. It's an affirmation of newness. And how do you affirm it? Who affirms it? The society affirms it by its acceptability and use and stuff like that. So I would expand on the term. So it's not only economics. It's a generic.
But it was born as economic concept.
Born, yeah, but
it was extended.
Yeah, they're born, but they're also applied to other areas.
Yes, you're right.
And so I would use innovation. I would not restrict it to economics. I would say that this is a process concept.
No, you're right.
Nagib.
Service innovation is a process concept. And the concept in itself could be a process one.
I mean, this goes back, I think, before at least large-scale economics, not business. Would you consider the scientific method an invention or an innovation? You'd say it's an innovation.
What method? There are many.
There are lots of them, whichever one you take, Jerry.
Methodological innovation. That's what the way I call it.
Yes.
Methodological innovation, and there is a lot of methodological innovation in industry.
And that is not
business.
Always because of economics.
Okay, not always for economics, but got to have some support from economics because all of that we have to have dinner and lunch.
I'm an academic, I don't know anything.
So,
let's look at something here, though. You talked about economics. Let's get down to the numbers. What generates economics? Going back to the primitive world. Economics, basically, go back to the Greek word, how that is. Economics means an exchange. Let's take the money crap out of it. I think money's good. I'm not talking about that, right? I'm not talking about it. Economics is an exchange. And so basically, I have an idea, exchange for something. What are we exchanging? So let's go back to the original, back to the cave person days of economics. I think that's where we're getting stumbling on this. And that's why I like to open it up beyond what would be money exchange. The economics of it, the Greek sense, that's where we're coming from. How it affirms itself in society by the exchange and the transmission from person to person in exchange and stuff like that. That's the underlying concept about money stuff. This kind of stuff right here. See, I like to get away from this stuff right here. This is only a symbol. It's only a symbol. So let's get to the basis of the symbol. That's what I want to. I don't like this stuff. So I want to get down to the concept, underscoring this, and that's the exchange. That's where we're coming from in innovation. So let's get rid of this and quit thinking about the money, banking, business, and stuff like this, and get in the substance of it. That's what generates this. The idea that generates this. That's where innovation comes from. I think there's a little confusion. That's how I can spend that term, apply to psychology, education, whatever you want to have.
So at least even in our disagreement, because we have some disagreement, there is some agreement. Innovation cannot be done just in one discipline. So any university talking about innovation should be also talking and planning interdisciplinary communication, at least interdisciplinary communication, if not interdisciplinary research. If they don't want to do that, don't talk about innovation because you are fooling people. Or at least say, hey, I'm using the word innovation in that sense, so you don't fool people. You are changing the definition of the word or the meaning of the word innovation. At least say it. Don't use it without alerting the reader. Please.
I want to say two things. One thing that you mentioned about economics, basic idea of economics. I was thinking that the basic idea of economics, not thinking about money, monetary, but less input, much output. Is this the basic concept of economics?
I'm definitely opposed, I can't agree with you.
Okay. You talked about the basic concept of economics.
Right.
Not monetary, but behind, just before the invention of money. Could this be like less output, less input, much output? Could this be regarded as a...
I will answer. I don't know his answer, but I will answer. That would be that would be an efficiency approach to economics, but not an effectiveness one. It's an efficiency one because you are relating output with input, less input, more output. So it's an efficiency one. So I will ask myself and you: can we limit economics to efficiency processes, or we should also take care of the effectiveness? In my opinion, economy should take care of the effectiveness, also not just the efficiency. Please.
All this stuff, again, it's all contextual. I think when it's like setting up any kind of a logical system, you want your definitions, you want your postulates, the axioms and stuff like that. So I think when you have a discussion like that, a very technical discussion, you want to set all that stuff forth. Again, I did not create a full substitute question. That's what I would do in terms of economics. I like etymology. So we go back into the point of really, what gave rise to the concept, and I would like to deal with those concepts at the basic level. So when there's efficiency, I have problems with that. We talk about being efficient in a society, that we become so damn efficient, we're killing ourselves. So what's efficient? I'd like to think efficiency would include the survival of the species. I don't think we're very good at that. So I'd be very cautious about when we use these qualitative terms, such as parameters of it, and knowing how you generate these parameters, apply them, and see the results. So we talk about efficiency in economics. I don't think we're doing a good job.
But some authors, I read some authors that have that position in economics, and I got this kind of reflection inside me. Gosh, they are talking about efficiency, not about effectiveness. Maybe I'm wrong, but this is what I felt when I read this kind of authors, you see. Maybe I'm wrong because I'm not an economist. So, but this is the feeling I got as soon as I read this kind of books or papers. But I am not an economist, so.
Just define your system. Give me your definition of the stuff.
So I think we have to work on the taxonomy here. I'm not really sure what you call a discipline at this point, but I can name a few. If I start writing down all the disciplines I know, it turns out to be a very large acyclic graph. Interdisciplinary falls where I don't have a term that has had sufficient interest and incentive to stimulate a research body of its own. So if we take this acyclic graph, which is huge and complicated and has a lot of connectivity that we wouldn't expect until we started analyzing it and breaking it down, each one of the nodes in that graph would be a discipline. Economic is actually one of those disciplines. And I would say that all of the disciplines need to touch that economic because they have to have generated sufficient interest and sufficient incentive for people to pull that body of knowledge together. Again, interdisciplinary exists between the nodes. So if you start thinking about between the nodes, then we have a number of people who are trying to pull a couple of disciplines together. A computer pulls electronics, information, mathematics, a few of those disciplines together, but eventually, if it's got sufficient interest and it's got sufficient incentive, it becomes a discipline of its own. So computer engineering, computer science become a discipline of their own. So I think if we're talking about the interstitial spaces between those nodes as the interdisciplinary, I think those are nascent disciplines. And as such, I think your premise is wrong, that if we're looking for necessary and sufficient conditions for the advancement of science, I think we need more than just disciplinary and interdisciplinary. We need the generation of the interests and incentive, some of which may be economic, some of which may be political, maybe other. We don't have to put time, money to things, but incentive is a good term that covers all of the things that drive people to look into certain areas. And when that becomes big enough, then what used to be interdisciplinary becomes a node in the graph, and it becomes a discipline.
So I would say, taking that into account, that I completely agree with what you said, completely. Because at least in these cases it should be necessary, at least, because there is more thing that should be necessary. I agree completely on that. I focused here on interdisciplinary because that was the thing that we saw as extremely important, and it's not being dealt with. I saw that, lived there for 10 years going to conversational session in Asilomar. For the first time, I went to a conference that I learned something. Not just presented my solutions. I learned something. There were 4 or 5 days of learning and analogical thinking. This analogical thinking comes because I'm listening to another discipline and I'm understanding what he's saying, and I'm trying to relate it to my disciplines, and then I'm getting some relations, some commonalities, and then that's the source of analogical thinking, which is the input of logical thinking. So from the personal point of view, I felt in love with the conversational conferences because the learning you get from them.
Yeah, I don't agree with this emphasis on economics. I do believe it's necessary and sufficient, and I'll look to mathematics as an example. We're ignoring what's been said is correct, but only if you take into account time. There are a lot of processes in mathematics that were developed because they were beautiful. People had interest in them. There was no economic interest in them. And in other disciplines, chemists needed description of groups, while the mathematicians happen to have it. Biologists today need descriptions of large networks. Well, it came from graph theory. The graph theory was an amusement. Euler wanted to know if there was a path between all the bridges in his town. In other words, so it's sufficient in the following sense. I'm a mathematician looking at things I like to look at. No one cares about what I'm doing. Then there are people like biologists and other people doing what they do, and they come someday and they have a problem that looks like something I've done. So the sufficiency is I've done what I like to do, they've done what I like to do, they like to do, and then at some point in time we merge.
Some point in time. Okay, some point in time.
The point is the sufficiency came before there was economic interest. The economic interest in graph theory and group theory may have come 100 years after it was developed. You can't say we have to take into account economic interest. In fact, one of the arguments of the academic world is they don't want the government saying, well, only do something if there's economic interest. And they point, I can speak for mathematics, but I think it's especially true there, to all the victories that have happened because a discipline that's existed for 100 years was waiting just when a scientific discipline needed. So I think it's sufficient and necessary.
Let me see if I can add something that will produce some agreement. We should probably define sufficient for what? If we define sufficient for what, then both reasoning would work.
Sufficient for innovation?
Oh, but if it is sufficient for innovation, then I don't see it without the other part as sufficient. It could be sufficient for the input to innovation, but not to innovation.
Okay.
You see what I mean? If you have a university that is saying in the web page with these letters, highlighted, innovation, what are you doing toward innovation?
On the other hand, following up on Jay's comment, calculus came about that sort of solution or would be solved more simply by those methods. And Newton discovered, invented, revealed, whatever one wants to think about mathematical truth. Calculus, Leibniz at roughly the same time, and maybe others. Partly for practical reasons and partly for aesthetics. Now, if you want to think aesthetics is an economic value, then. But you can't just view that as an invention. A unified approach to calculus is an innovation. It allows you to look at a raft of problems in a very different way.
Ended up in an innovation because he's using that 500 years later.
But it was immediately.
So it's an innovation 500 years later that he's using it. But someone has to use it in order to be innovation.
I don't think so.
Yeah, but that's the concept.
I'd like to answer that.
Yeah.
I mean, there are lots of ways to look at calculus, but let's go back to the 13th and 14th century. Tycho Brahe spent 20 years looking at planets. Now, astronomy is the study of planets. He finds the study of objects. He had data for 20 years, I think the 14th to 15th century, and he formulated 3 laws of the planetary motion. In the meantime, René Descartes came up with the idea that we shouldn't separate algebra and geometry, invented Descartes into geometry, and that led in part to the calculus. So the point is, the sources for both these things came in part from totally distinct and disparate disciplines. Once the calculus came about, Newton was instantly able to apply it to Tycho Brahe, but he didn't invent the calculus to solve Tycho Brahe's problem. He invented it. Well, you'll have to check on that. He invented it as a consequence of Descartes geometry.
Yes.
We were told not to look at algebra separately and geometry separately. And then lo and behold, this accident happened. That's what I mean necessary and sufficient. Necessary and sufficient for interdisciplinary accidents. This accident happened that after he took Cartesian geometry to its logical conclusion, he found that what Brahe worked on for 20 years can be done in one page without any experimentation. And so I wouldn't call it instantaneous. I'd say it happened over 200 years.
That might be a good example for the next question. Do the following, the next one, the next slide. Systemic-cybernetic relationships make any sense to you? If not, why? The system approach focuses on the relation between the objects. The cybernetic focus on those relations that provide some feedback, some feed-forward, some negative or positive feedback in order to study them. Cybernetics is not just that. This is part of cybernetics. So when you focus on the relation in that graph and that node, not in the nodes, but in the relation, you are making explicit what was implicit here, that the relation produced that, thanks to the two nodes. So we needed a node, the 2 nodes, that we needed someone or some people to focus on the relation in order to get the relation that was the innovation. You see what I mean? So this is why I'm taking his example as example of a systemic approach, a cybernetic approach to knowledge, in order to relate knowledge by synthesis.
Let me say one more thing in regard to the network, and it connects to something we're going to talk about later, as well as something I said before, that each of the disciplines has approaches and answers. The interdisciplinary lies in looking at that link and saying what questions are alive on this link.
Yeah,
That don't have. So the
in fact, a more
interdisciplinary.
generic form of the graph is an entity relationship diagram. In this particular case, the entities are disciplines, and the relationships are interdisciplinary.
And the budding disciplines become, if you want, generalizing UML or SysML association classes attached to the edges, where questions are generated. Gradually, that factors the edge, or at least in part.
What are the confusing, I think one of the issues here is that I'm going to do with mathematicians. I think there's an analogy to be drawn here. Now, is pi a number?
Yes.
And the process.
No, is pi a number?
Yes.
No.
It's actually a
I would
relationship.
argue that it's not. I would argue that any irrational number is not a number, and I'll tell you what it is. It's a process. And I think it's one thing I think it's what's happening, a lot of it, we get focused on objects. But you know, objects are very slippery. And I think pi is one of them. And some of these other, it's a relationship. It's a process. We think it's a number. You think you can make a number out of it, but it's not really. It's a process. It's a relationship.
The problem is, Jeremy, that it's too many relationships at the same time.
Maybe, but
If it only came up as the circle relationships, it would be one thing that also comes up in probability and in a raft of other places. So you have to, it's a class of relationships if you want.
you know, I would wonder if it's not a process. I think a discipline, and what I'm saying, I'm getting at, is disciplines in the same way. The same, I would say, it's somewhat analogous to that relationship, that the way you come about the identification of something, what you think is a discipline may not be a discipline to somebody else. I mean, what I'm saying is I think it's process related, what I'm getting to. You were saying something about that's why I look at pi, is that I don't see it as we think it's a number or something like this, but we kind of conveniently call it that. But I would argue that's more of a relationship and a process rather than anything else.
Well, one of the properties of pi is numerical, but there are more properties inherent in pi than just that numerical value.
Yeah.
And it has to do with the things it ties together, which makes it a relation which has properties,
Right.
one of which is numeric, the other which is probabilistic, the other which is geometric.
It's a process.
So on and so on.
And so on and so on.
Jeremy, the approximation of its value is a process. That's what he's trying to say.
Right.
But in itself, mathematicians consider it pi a number no different than 1 and 2. Now, you and I consider it different because I can say 1, 2.
Right.
I can even take a pi and cut it into quarters. But I can't produce pi because to produce it I need approximation. But the mathematicians consider the fourth dimension real. They consider pi an object like anything else. If you use numerical values, a process. But you may want to describe the relationship between the area and radius, and it's not a process, it's an object. And that's what he was saying. And you may want to describe probability, and then it's an object. Its value will always be an approximation, but it's a real thing. It's just not as much an object as other things where we can grab them.
We are getting in something that we can spend the next 1,000 of years with that, because there have been at least 2,000 years with discussion about that. I just want to bring to your attention this thing. That will take maybe another hour. We're not going to do it. But just think about the questions. Is there any association between academic ethos, pathos, and logos, and relating explicitly disciplinary research and interdisciplinary communication and research? My very subjective, extremely subjective opinion is that if we don't agree with that, at least say it, in order to have some academic ethics. You don't have to agree, but say it.
There's
For example, in our universities, they say that they are high education. This is another topic that's coming later. Okay? I've been 30 years telling my students we are fooling all of you because you are not getting higher education in this university, you are getting higher instruction. So please go and say that to your parents so they can feel the help of education that this university is not giving you. Because this is higher instruction, which is necessary for education but not sufficient. Stanford is at least one university, maybe are more, maybe it has more than that, but at least Stanford is providing now to the undergraduate student and to the graduate student what they call novo trivium. And as you know, trivium is the medieval trivium, which is to talk correct grammar, to know how to dialogue, dialectic, and rhetoric. But rhetoric in the good sense, the rhetoric needs ethos, because if you want people to convince people, you need people to believe in you, what you are saying. It means, rhetoric means to talk effectively, so you can communicate effectively, not efficiently, but effectively, your opinion. And then you need somehow to transmit the emotion that your students need to get what you are telling them. If you are empty of emotions, how you're gonna transmit emotion to your students? If you are a machine talking, how you're gonna transmit any kind of emotion? So my question is, and you can answer in a different way in the optional paper you have, is there any association between alerting about the interdisciplinary necessity for at least university talking about innovation? Is there an ethical problem here if we don't alert? That you are saying that you are doing that, but you are not doing that. We've been talking about that, about the disagreement we have here, and you saw the disagreement here. Okay, so this is why I prefer to start with something more logical than interpretable. Okay. And I really would love any of you to take their arrows and start shooting and killing that diagram. Interdisciplinary research and communication, they have or should have, in my opinion right now, they have indirectly and implicitly a cybernetic relationship. If we make this cybernetic relationship explicit and we plan according to this explicitness, we will be more efficient and effective. Both things can be said. This is going on in an implicit way, in an indirect way. The proposal is to make it explicit in order to plan between both of them. If we do that, we don't need to agree with Jeremy. If we agree with him, better. But if we do that, we don't have to agree with positions like Jeremy's in order to be useful to the industry, private and public corporation, and in general to society. If we agree with him, better. But some people would not agree with him. So even with the people that cannot agree with him, they can find a way to take the university, the research institute, the higher education, to provide input to the society and to business. And with this input, we have the innovation that the industry and the business produce. So if the university is not looking to produce innovations, at least be clear about that and produce some previous product that would generate some innovation in the society and make it explicit. Because if it is implicit, it's going to take more time and probably more resources. It's going to be implicit and indirect. But if you make it explicit, you can plan it. And you have the chance to make it more efficient and effective.
one problem with that is exactly what Jay brought up earlier, that certain disciplines, mathematics, theoretical computer science, theoretical physics, art, are building resources that whose use can't be anticipated.
Yes.
You are storing in libraries and granaries and effective material that can be used later, and you don't know why. And you don't know how. And you don't know which. But if you cut that off, you're cutting off way too much long-term productivity. Developing the mathematics when you need it is no guarantee of success, and is a lot less efficient and a lot more time-consuming and a lot harder to get funding for than having it sitting around.
I'm not trying to say that everyone should do that. Probably some individual would like to do that ineffectively like me, okay? But the idea is the organization of the university. The organization should have people like what you are saying, because this is the support of everything. But they should be clear about the other things that they need to be doing in order to provide the adequate input for the innovation in the society. Because it's even an ethical problem. The society is supporting all of us. We should give something back. And through interdisciplinary communication research, in my opinion, and this is a practice-based opinion for 4 years in practice, if you have some promotion, if you have department bosses that take into account that for your promotion, and you have grant for that, and you have financial support for that, then you are allowing that to go to the society. So I would say that probably there is an ethical problem in the academic world to implement not all of the university, but part of the university to be oriented to interdisciplinary research and interdisciplinary communication, and to give the promotion for this kind of work.
You have to shoot arrows at that, so there's one place I can shoot an arrow. The bottom rectangle, corporations, industry, they care about instant money. They will do something if they can get money. The top, the academic world, and this has been pointed out before, they just care of producing new ideas and papers. So I was thinking of one thing, so along the lines the people here have said. In 1990, there was a discovery was made between the anthropologists and mathematicians. Now, anthropology is the study of primitive societies. It's a discipline. It's a discipline because it's defined by what it studies. It could go on for thousands of years and never have come up with this. Mathematicians will study group theory, which is a mathematical object no different than pi, process, definition, whatever it is. They've been studying it. And what they discovered was that the patterns on various tribes and other things, the patterns on their dresses, their vases, their quilts, and everything else, that each tribe, some invariant group of it, was distinct. This was totally unexpected. No one would have spent a dime to discover this, but it created all kinds of excitement because here is something, the disciplines were well defined. They could have continued. They discovered something because they were talking to each other, which is what you want done. My only issue is you have to convince someone to pay for it. And no one's going to pay for it. The people who hold the money will say, what have you produced, what will you produce? Group theory existed for 200-300 years. Anthropology existed for longer. No one expected this to happen, but it just happened. I myself don't know. I know the people involved. I don't know how they happened to meet each other, but they discovered this. And the point is, we have to create that bottom arrow We have to convince the people with money that we're spending. Now, some industries do that by giving a small amount to certain types of speculative research in the ground that it produces something. And that is an enormous burden on the people working. They suppose they don't produce. So that's sort of the paradox there.
Yeah, if I understood the thing, I would say yin and yang. I mean, why we should see that as contradictory opposite, contradicting each other, which is frequent in academy, to see both things as contradictions. Why we cannot see it as polar opposite? You see, warm and cold, and then you have the intermediate things, but they are opposite, but they do not contradict each other. In academy, we see these people contradicting us. And these people, many of them, because I had the experience working as consultant, see us. I had to remove from one of the papers that I am PhD, because they wouldn't contract me as consultant because I am in another world, you see, so I have to remove from the. So I understand what you are saying, you see, but still it can be seen not as contradiction but as polar opposite, you see, here. And here, again, inside this, there is a polar opposite also. Both of them can be seen as related like the yin and the yang.
Someone had a question.
Thank you for that. I miss two things, I think. First of all, the role of political actors, because they are very important in the whole process of knowledge generation and knowledge acceptance and etc. And second, I miss a little bit the idea that there is a very hierarchy between the disciplines. Mathematics is very king of disciplines, as they describe themselves as kings of discipline, and there is pedagogy or archaeology, etc. And there is a lot of interdisciplinary research and communication all around. But it is really a big difference, especially for political actors, who communicate. A mathematician or an archaeologist or a social. And last point, the real life problems. I don't know whether I understand your notion of that real life problem in the right way, but I'm afraid that there is a very, or you use it as a very objective term. And I think real life problems are deeply socially constructed. So is poverty addressing, for example, or is the topic addressing that we don't have big enough economic development rates, etc. So just a few comments.
Because my objective as a scientist, let's suppose I'm a scientist or not, my objective as scientist is your subjectivity. Because you are constructing the reality around you.
That's right.
So my objective is your subjectivity. So there is no contradiction between objectiveness and subjectiveness. I am being nurtured by your subjectivity. You are my object of study, but your subjectivity is my object of study. So there is no contradiction. On the contrary, there is complementarity between objectivity and subjectivity. So I did to, like, I'm thinking, you started talking about the politics, and I started thinking to myself, I'm going to write that down because it's right. Because if I write it down, I might provoke some different kind of feelings. And perceptions are sometimes dominated by feelings. And I hear you. But I don't know now if, from the feedback I'm getting, I will aggregate it. I will add it. But if I don't do it, it doesn't mean that I don't agree with you. We have the next one.
Just in terms of this starting proposition of the disciplinary research is necessary, interdisciplinary
have a sufficient number of social scientists who are interested in solving societal problems. I'll give you an example. There's, for example, a very interesting faculty of social work in the University of Bolivar. There's of course a sociology department. But this faculty, which I found very interesting, they have a totally different approach to problem solving. So if there's a disaster, they're not studying the disaster, but they work in disaster relief. If there's an international disaster, they are traveling there and they actually do something. They are involved in helping or in some part of analysis, but mainly they are active in doing something. And in terms of necessary conditions, you need disciplinary research, you need interdisciplinary research, but if you have both of them, you are not sure that you can, at the level of solving social or societal problems, you need also a group of activists who are actively engaged in doing this.
You're right. Maybe you are.
This shouldn't be forgotten.
Yeah, maybe we can retake that in the last conversational session about how to relate all these kind of things. Where we'll be talking over there with social engineering, but in the good sense, not in the leftist sense, but in the academic sense. Social, organizational engineering, which should be working with sociologists, because the sociologists are more inclined, I'm not telling all of them, to describe what they are seeing. An organizational engineer describe what it might be, not what it is. So in that sense, I see the sociologist making a good complementary with organizational engineers. You see, the problem I have with the sociology is that they are a necessary condition, but not sufficient, because they are used to say what it is, not what it might be. You see what I mean?
Do this in the next session.
Yeah, you're right. So you are the best attendee here to present the next speaker. No, I prefer you to present it.